Today it's CCNA 200-301 day 16, and today we're going to be covering OSPFv2. So the exam objectives today are configure and verify single area OSPFv2. And OSPF routers discover their neighbors through hello packets. Key components of the hello packet include a router ID, which is a unique identifier for each router, hello interval, which is time between hello packets, which the default is 10 seconds on broadcast and point-to-point networks. There's a dead interval, where it's the time before a neighbor is declared down. If no hello packets are received, default is 40 seconds on broadcast and point-to-point networks. You'll see this on the test probably, because it's like 40 seconds, and then it'll be like, so whatever, 20 seconds, and then you'll be like, oh no, the default's 40 seconds. I think that you might see that. But subnet mask ensures that routers are on the same subnet. Area ID is routers must be in the same OSPF area to form adjacencies. Authentication is must match if OSPF authentication is configured. Router priority is used in the election of designated router and backup designated router. DR and BDR IP addresses indicate the current DR and BDR in the network. So, what are the states of OSPF? OSPF routers go through several states to establish an adjacency. There's the state of down, where no hello packets are received from the neighbor. There's init, which is hello packets are received from neighbors, but the receiving router's own router ID is not listed in the hello packet. There's two-way, where it's bidirectional communication established, but this is the stable state for neighbors on a broadcast and a non-broadcast multi-access networks. So if there's no DR or BDR election that's needed for this one, where it's two-way. X star is negotiation of master and relationship. Maybe this can't be said for copyright. Relationship and DBD sequence numbers. So that's how that works. The exchange is exchange of DBD packets containing LSA headers. Loading is requesting more information about routes advertised in DBD packets, and full is complete adjacency established and the routers are fully synchronized. So, neighbor adjacencies on different network types. OSPF behaves differently depending on the network type. So there's broadcast and non-broadcast multi-access, or NBMA, where routers elect the direct router and the backup direct router, designated router, and the backup designated router, to reduce the amount of OSPF traffic. Full adjacencies are formed only with the designated router and backup designated router. Point-to-point is where routers form a full adjacency directly with their single neighbor. Point-to-multipoint is each router establishes adjacencies as if they were point-to-point links. And then there's virtual links used to connect disjointed OSPF areas. OSPF point-to-point networks. OSPF point-to-point networks are used in scenarios where there is a direct connection between two routers without any immediate devices or intermediate devices. This type of network simplifies the OSPF neighbor relationship because there are only two devices involved. So you can see the area. It's a point-to-point network. OSPF neighbor states in point-to-point networks. The OSPF neighbor states in point-to-point networks are similar to other OSPF networks types, but they often reach the full state more quickly due to the simplicity of the topology. States are down, init, two-way, X star, exchange, loading, and full. Hello packet exchange. So in point-to-point networks, routers exchange hello packets to discover networks and establish adjacencies. The key components of hello packets include the router ID, which is a unique identifier for each router, the hello interval, which is the time between hello packets, the dead interval, which is the time before a neighbor is declared down if no hello packets are received, the subnet mask, which ensures the routers are on the same subnet, area ID, which ensures that the routers must be in the same OSPF area to form adjacencies, and authentication, where it must match if OSPF authentication is configured. The advantages of point-to-point networks is the simplicity, where only two routers are involved, making the network simpler to configure and troubleshoot. And there's also efficiency that comes with this, where there's no need for DR or BDR elections, reducing the OSPF overhead. And then there's also the benefit of speed, where there's faster convergence and establishment of adjacencies due to direct connection. So, configuring these point-to-point networks. Let's find out how. So enabling OSPF on point-to-point networks is straightforward and simple. Basic steps include enabling OSPF on the routers, which is just through router OSPF1. Do this in Packet Tracer and follow along if you want to configure it yourself, or just watch a video. And configure the OSPF area as simple as just network, and then you put the network address you want. A wildcard mask is just an inverse subnet mask. So if there's 255.255.255.0, it's 0.0.0.255, and that's all a wildcard mask is. And then area, and then the area ID that you have. Then you'll have area, the OSPF area configured. So OSPF broadcast networks. OSPF broadcast networks are used in environments where multiple routers are connected over a common broadcast medium, such as Ethernet. In these networks, OSPF elects a DR and a BDR to minimize the amount of OSPF routing traffic and simplicity the neighbor relationship process. So it simplifies it. They connect multiple LANs and MANs, facilitating communication and data exchange between different locations. The selection of DR and BDR is a key process in OSPF broadcast networks. The steps involved are hello packet exchange, where routers on a broadcast network exchange hello packets to discover networks and gather information about the DR and BDR. There's priority and router ID, where the selection is based off of the OSPF priority. The default is 1, and the router ID highest IP address if priorities are equal. A priority value of 0 means the router will not participate in the election. So the election process is the initial election. When OSPF starts, all routers declare themselves as the DR or BDR if they have the highest priority or / router ID. The DR election is the router with the highest priority becomes a DR. If priorities are equal, the router with the highest router ID is selected. Then the BDR is the one with the second highest, and then that one becomes a BDR. So OSPF neighbor states in broadcast networks. The OSPF neighbor states in broadcast networks are similar to those in OSPF network types, but with some specifics in the DR and BDR. So there's down, init, two-way, XSTAR, exchange, loading, and full. And if you want to read these, pause it. So DR and BDR responsibilities. The DR, right? These responsibilities are for generating and distributing LSAs, or link state advertisements, to all OSPF routers on the network segment. The BDR is a backup to the DR, and if the DR fails, then the BDR takes over as a DR. Hello packet contents are in broadcast networks which contain additional fields relevant to the DR or BDR selection. So, DR and BDR IP addresses indicate the current DR and BDR on the network. Priority is used in the DR/BDR selection process, and router ID is a unique identifier for each router. Configuration for these is also quite simple and straightforward. Router OSPF1, then you do the network and throw in the network address, wildcard mask, and area. And then interface, and you do whatever interface, like G01 for example, and then IP, OSPF priority, and whatever. That's how you pick it. That's done. Done deal. You have OSPF configured. So, what's the definition and purpose of the router ID? The OSPF router ID is a 32-bit number that uniquely identifies each router in an OSPF network. It is essential for OSPF operations as it helps in identification of routers when establishing neighbor relationships and exchanging routing information. Determination of the router ID is happen based on the following criteria in order of preference. So it's manually configured, and then the router ID can explicitly be set using the router ID command within the OSPF router configuration mode. So it's router OSPF1 and the router ID, and boom. So then it's the highest IP address of a loopback interface. If the router ID is not manually configured, this is connected to this one by the way. If the router ID is not manually configured, then the OSPF will use the highest IP address of any loopback interface. And then if that's not there and there's no loopback interfaces, then the OSPF will choose the highest IP address of any active interface, like physical interface. So, what's the importance of the router ID? The router ID plays a critical role in OSPF operations. Neighbor discovery. Routers use the router ID to identify each other when forming OSPF adjacencies. LSA identification. The router ID is used in identification and origination of link state advertisements. And then DR and BDR selection. In broadcast and non-broadcast multi-access networks, the router is used in the DR and BDR election process when priorities are equal. So, changing the router ID. If the router ID needs to be changed, it can be done using the router ID command. However, changing this requires resetting the OSPF process for the change to actually take effect. So if you do the command, it'll do nothing until you reset the OSPF process. And to change the router ID, it's just router OSPF1, and then after that, router ID, and boom. Then you have to reset it, so you do this command, clear IP OSPF process. Thanks so much for watching, guys. I hope you learned about OSPF. This is a great coverage, and I wish you good luck in your studying. Make sure you do a lot of practice questions, and make sure to drop a like, comment, and subscribe if you like these series. Thank you so much, and see you soon.